All right, so for this problem, you're on board an LCS, and your captain wants to take the LCS just inside the littoral zone, so 599 feet offshore, just barely inside. And he wants to know, is it safe to anchor at that point? And you know that the ship has a draft of 15 feet, and you know that you need at least 5 feet of water beneath the keel in order for the ship to be safe. You know that the grain size of the beach is 0.90 millimeters and that you have an equilibrium beach profile. So the first thing we need to do is we need to decide, okay, based on that information about our ship, how much water depth do we actually need? So it's not terribly complicated, right? So if this is your LCS, right, it tells you that the ship has a draft of 15 feet. So the distance from the water line to the keel of the ship is 15 feet, and you need at least 5 feet between the keel and the bottom of the ocean. Therefore, we need at least 20 feet total of water. Okay, so that's what we're looking for. We're looking to see, is the water depth greater than or less than 20 feet? So again, we have our equilibrium beach profile. The water depth is equal to our constant A times the distance from shore to the 2/3 power. And we're going to get our constant A by looking at our table of A values, right? So we go and we see it's based on the diameter. So our first digit of our grain size is 9, 0.9. So we look down on the rows and we go all the way to the row that is 0.9. That corresponds to first digit. And then we look at the second digit of the grain size, 0.0, and we use that to determine which column we want. So we go to the column that reads 0.00, right? Because that's telling us the second part of the decimal. So if we look in that row in that column, it tells us that our value of A is 0.202. Now remember, those values of A are given in meters to the 1/3 power, right? However, the rest of our units for this problem are in feet. So we're going to have to do something with that unit conversion. So there's two different ways you can kind of do this. The first way is that the table tells you, right? If you look in the fine print at the bottom, it tells you that if you need to use it in feet, you multiply by 1.49 to convert from meters to the 1/3 to feet to the 1/3. So what that looks like is you say d is equal to a times x to the 2/3. Therefore, d is equal to 0.202 meters to the 1/3 times 1.49 feet to the 1/3 per 1 meter to the 1/3. And then our distance from shore is 599 feet to the 2/3 power. Therefore, our distance from shore is 21.4 feet, which is greater than 20. Therefore, ship is safe. Safe is safe. Ship is safe. So where does that 1.49 come from, right? That's a super weird number. So the other way you can think about this unit conversion is based on what you already know about feet and meters. So if we were to do this problem separately, I would say I have my A value, 0.202 meters to the 1/3. Now I want to convert meters to feet. I don't know what meters to the 1/3 unit conversions are, but I do know that there are 3.3 feet in 1 meter. Some places will sell you it's 3.28. I don't think that's a serious enough difference to really matter, right? Now, the same way when we convert, say, feet squared to meters squared or centimeters squared to meters squared, we have to throw that squared on our unit conversion. Since we're converting meters to the 1/3 to feet to the 1/3, we take this value to the 1/3 power. And then our x, again, distance from shore, 599 feet to the 2/3 power. Now, if you go on your calculator and you evaluate this 3.33 to the 1/3, hopefully it doesn't surprise you that you get 1.49. And that's where our 1.49 feet to the 1/3 per meter to the 1/3 actually comes from And look at that, you still get that the distance or depth is 21.4 feet. So again, when it comes time for tests or anything else, you can read that unit conversion off the table. It is in the fine print at the bottom of the table. Or if for some reason you don't like that, there's where that 1.49 comes from. It's the actual straight up unit conversion of feet to meters taken to the 1/3 power.